हाँ हुआ स्टार्ट हो रहा है.
Fine. So let's start with the prayer, beta.
Okay, ma'am. Bismillahirrahmanirrahim. Alhamdulillah Rabbil Alameen. Ar-Rahmanir-Rahim. Maliki Yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين.
Good morning, all of you.
Good morning, ma'am.
What's written for the thought of the day? That every home is a university and the parents are the teachers. So, who is the first teacher for all of you, beta? Hello. Who is the first teacher for all of you? They are your parents, mama and papa. Do you understand? Someone's mic is on, beta. So, you got to learn. The first school is your home where you are born. That is your first school. The second school is the school that you go to with your bags. Now you got it? So you learn most of the things from your parents. So it's always like charity begins at home. Remember that? So what you are, your personality, your behavioral aspects is all made from home. Do you understand better? So it's not a school, but it's a university. So you learn so many things from home. Okay? Can you hear me better?
Yes, ma'am.
Did you find any problem so far in this chapter? Yes? Last week, did you find any problem, Peter? So far, this was the last slide that we did. Remember, hydrogen atom is the smallest, and we had given the radius regarding hydrogen is the smallest, and followed by nitrogen, and iron is the biggest in the list. Now we will do representation of atoms. That means if I want to know what is hydrogen atom, I have to show that this is what is hydrogen atom. So what do you have to do? You have to symbolize it. Yes, beta? You have to give symbols for all the elements. Then only we can understand that this is hydrogen and this is nitrogen. Do you understand? Boys, do you understand?
Yes, ma'am.
Hello? Yeah? Okay. So, who was the first scientist who worked on this aspect? Who realized that we have to identify the elements by giving them symbols. And who was the first person to do so? It was Dalton. Yes, better read. Read better. Start reading. Hello, start reading better.
3.1 The representation of atoms. Dalton was the first scientist to use elements. Every symbol gives
No, to
a
use symbols
proposed
better.
representation.
Hello, to use. Who is reading? Who is reading better?
My
No, I know. What's your name?
Rehan.
Rehan. Rehan, after used is symbols which is written in white ink. Please read that as well. Symbols to represent different elements. Right, beta? Can you read it or not? Can you see on the slide?
Dalton, yes.
Hmm. Read.
Dalton, Dalton was the first scientist to use the symbol to represent different elements. Every symbol he proposed also represented a definite quantity of the respective element. The symbol of some some common element
Elements
common element
as
is
proposed
proposed by the Dalton and are shown
by
in
Dalton,
given
beta.
figure.
There is no the Dalton, please. You cannot put the before a name. You should know that. It's a proper noun and you cannot put the in front of the proper noun. Is it clear? So it is only by Dalton. Understood, beta?
Yes, ma'am.
Understood? Okay, fine. So Dalton was the first scientist to have given the symbols. So he was the first scientist to give symbols so as to identify different elements, and the symbol that he gave also it shows that this is the quantity of the particular element. Let's see what are the elements he has worked on. First one, let's take up as hydrogen. Can you see this? That's how he symbolized hydrogen. Carbon was put a just a circle. Oxygen was also given a circle. Phosphorus you can see triangular. Sulfur four quadrants. Iron like this. Copper to put C in between. Lead, silver, S. You can see over here gold. Platinum is platina, mercury. This is how he has put certain diagrams to show those particular elements. You understand? It did not work well. Remember that. Because carbon and oxygen looks almost the same. The only difference is that carbon has got white inside the circuit is white, whereas it is dark. That's the only difference. Okay, boys, boys.
Yes, ma'am.
Hello. Yeah. So you understood what I tried to show? This did not work because there are so many elements. What type of symbols you will put? They may be overlapping. You're gonna come up with so many ideas to show these diagrams, right, beta? So there had to be something else which can work as a better symbol. Okay, I will read it. However, these symbols of elements as proposed by Dalton were difficult to draw. You understood? And remember why his work did not become noticed was that how many diagrams you will draw, and is it so easy to remember those diagrams? No. So एक one alternative method of representing elements were proposed by J. Berdelius. He suggested the alphabets can be used as symbols to represent the elements. Further, these symbols can be made from one or two letters of the name of the element. You understand? So there was another proposal after Dalton because Dalton's symbol did not work well. I showed you the disadvantages as well. So other scientists, Berzelius, suggested that let's give certain symbols or let's take alphabets as symbols and work on it. Now the symbols that we are using these days, that's the modern symbols of elements, they took this idea and we have one IUPAC system that is International Union of Pure and Applied Chemistry, which approves the names of these elements. Also, it approves the symbol of the element made from one or two letters of the English or Latin name of that element. As a rule, the first letter of a symbol is always written as a capital letter and the second letter as small letter. Have you understood this? So we came across a system which is known as IUPAC system. So this IUPAC system is working on the beta name of the element. For example, it's copper. So C becomes capital and U becomes small. This is how we symbolize copper. You understand or not? Hello? Hello?
Yes, ma'am.
Yes. Did you understand what the first letter has to be taken capital and the second letter has to be taken as small letter? This is how we symbolize the elements. And who has given this sort of recognition is IUPAC system, this International Union of Pure and Applied Chemistry, and all of us have to follow this system. It's universally recognized. Understood, beta?
Yes, ma'am.
The modern symbols of some common elements are given in the following table. You have to learn all these things better. Because if you do not know the symbols, it will be very difficult for you to carry forward. Because later we have to work with the equations, balancing the equations, so we should be well versed with the elements. The symbol of the elements, the name of the elements. Do you understand? So start learning right away. Whatever data I'm giving you, this is your homework. You have to learn it by heart. There's nothing to understand over here. You have to learn it. That's it. So let's start with aluminium. It is Al. I told you the first letter and the second letter. Generally, we take it like this. Argon, you can see Ar. Calcium, Ca. Carbon only C. Because you can see, if I take Ca over here, then there will be no differentiation between C and C. Is it understandable? That's why the A is removed from carbon. Have you understood, beta? Hello. Hello, boys. If you can hear me, say yes at least.
Yes, ma'am.
Okay. So you understood that what is the difference between calcium and carbon? Both have got CaCa. Can you see this over here? See, both have got Ca. But then how can you identify which one is calcium and which one is carbon? So from C, carbon, this is removed. So we have put only C to differentiate between calcium and carbon. Have you understood? Yes, chlorine. Now H is silent over here, so we have not taken H, so instead we have taken Cl. Copper, it is Cu. Then we have fluorine, it is F. Gold, Au, hydrogen H. Iron, Fe. Lead, Pb. Magnesium, Mg. Nitrogen, only N. Oxygen, O. Potassium, K. Silicon, Si. Silver, Ag. And sodium is Na. Hope you have understood. These are the basic elements with the symbols. Please learn it by heart. Okay?
Okay, ma'am.
Read.
Symbols of atoms of different elements. The symbol of elements are represented by letters. The symbol of some elements are represented by one letter, and the symbols of some elements are represented by two letters. If the symbol has only one letter, it should be written as capital letter, and if the symbol has two letters, then the first letter should be capital letter and the second letter should be small letter.
I think this is revision. We have already done this, right, beta? First letter capital, second letter small letter.
Yes.
Otherwise, only one letter, then that letter has to be capital. Okay? And we have done this already. Something more to it is, let's do it again. Something extra elements. Will you read or should I read, beta?
Name you read.
Okay. Aluminium Ar, argon Ar. Now, new one we have got it as barium, Pa, boron, B, bromine, Br, calcium carbon we did, chlorine, Cl. Is it understandable? Yes? Now, copper, instead of symbol putting here U, hydrogen H, iodine I. This we have done, iron, lead, magnesium. Come to nitrogen N, oxygen O, potassium with it, silicon with it, silver also with it, sodium also, sulfur S, uranium U. Understood? These are the extra information that you got it now. Everything you have to learn it by heart. I repeat again, you have to learn it by heart. So let's come to a very new topic, that is atomic mass. Very important. Read better.
Atomic mass. Mass is a characteristic property of matter. Hence, the atoms present in matter also possess mass. The mass of an atom is known as the atomic mass.
Continue.
Atoms of a given element are identical in shape, size, mass, chemical properties, etc. Atoms of different elements have different masses and chemical properties.
Now, we know that matter has got mass. Earlier, when we started with the chapter, what we have come to know? That all matter has got mass, whether it is liquid, whether it is solid or gaseous. Right, beta? Hello? Is it right?
Yes, ma'am.
Yes. This is how we have started. That all matters have got mass of its
Yes.
own. So, it is a very important property of matter. So, what is matter made up of? Atoms. That also we know, isn't it? So, atoms also has got masses. From where the masses come? Solid is made up of atoms. So, atom will also have some mass, right, beta? So, when the atom is having the
Yes.
mass, so atom with the mass becomes atomic mass. So, the mass of an atom is called as atomic mass. Now, take any element. For example, let's take gold. Okay, beta. So, atoms of gold, all the atoms of gold will be identical. How? They will be identical, that will be similar in shape, size, mass, chemical properties. Am I right?
Yes, ma'am.
Yes. So, all the atoms of gold will be similar in size, in shape, in mass, and in chemical properties. So, all the atoms of gold will be same regarding shape, size, mass, and chemical properties. Whereas they will be different for the different elements, isn't it? So the gold will be different than silver. Simple. So atomic mass of gold will not be the same as atomic mass of silver. Do you understand? Because they are from the different elements. Have you understood all of you better? Hello.
Yes, ma'am.
Okay.
Yes, ma'am. Understood.
Okay. Now again we are revising it. The atomic mass. Start.
Atomic mass. Since atoms are very small in size, its mass is very small, and determining its mass is very difficult. So, the mass of an atom is compared with the mass of a standard atom. The atom which is considered as a standard form for comparing the masses of other atoms is carbon. 12 atom whose
12.
atomic masses is 12 atom whose atomic
U.
mass is 12 U.
12
Atomic
U.
mass unit.
Exactly.
Yes, 12 unit. One atomic mass unit is the mass of 1 to 12 the mass of a carbon 12 atom.
Okay. Done? Now, atoms are so small
Yes,
in
ma'am.
size, okay, thank you, that their mass has to be very small. And do you think it is possible for us to find out the mass of the atom? No, it's very difficult. So, we have to have a reference. So, we take one atom as a standard atom and we compare the other atoms with the standard atom. Do you understand? Now, here we are taking the standard atom as carbon atom. Am I clear?
Yes, ma'am.
Yes. So we have taken a standard atom as carbon atom, and with that atom we are comparing other atoms, right, beta? Now, standard atom we are taking for comparing the masses of other atom is carbon 12. Now, what's the atomic mass? Obviously, it's 12 unit or 12 atomic mass units. So carbon's mass is 12 atomic mass unit. Is this clear?
Yes, ma'am.
Yes. Okay. So one atomic mass unit will be obviously 1/12 of the mass of the carbon atom. Am I right? If I'm comparing one atomic mass
Yes,
unit
ma'am.
as standardized by carbon, so obviously it will be compared as 1/12 of carbon. Am I right?
Yes.
Yes? Okay. So what is atomic mass of an element? Is the average mass of one atom of the element. What is the average mass? One atom of the element as compared, as related with 1/12 mass of the carbon 12 atom. Is it clear? So we are comparing any atoms of the particular element with standardized carbon atom as 1/12. How are we comparing with a 1/12 of the carbon atom? This is how we are comparing the atomic mass of any element.
Yes.
Yes.
Now you can see over here is given hydrogen has got the minimum. How much it is? 1. We know carbon is 12 and you know it is the standard. Carbon has been taken as a standard. How much it has got? 12. Nitrogen 14, oxygen 16, sodium 23, magnesium 24. It's all is atomic mass unit, U. Aluminum 27, sulfur 32, chlorine. This is the only atomic mass which is given in the decimal. Please understand that. Everywhere it is a whole number. See, you can see everywhere it is whole. There's the only decimal in chlorine. Am I right? So in the whole
Yes,
list,
ma'am.
chlorine is the one which has got decimal. It is not the whole number. You know that, no? It's not the whole number. Whole number begins from where? Which is the whole number, beta? Boys, do you know what is different between natural number and the whole number? Hello, please make it fast. What is the difference between natural number and the whole number? Do you want me to give the answer? Hello.
Yes, ma'am.
Do you have the answer? Do you want me to give the answer?
One question.
Hmm? Do you know the answer or not? See, 0, 1 to 3 is whole number, whereas 1 to 3 is a natural number. Am I correct? Yes, so what is the number that is differentiating whole number with the natural number? It is 0. So 0 plus natural number is the whole number. Is it clear?
Yes, ma'am.
Yes.
Yes, ma'am.
So you can see everywhere it is whole number except chlorine, which has got, so it becomes a fraction, isn't it? 35.5, so 35.5, you take out the decimal, it becomes divided by 10. So it has got a numerator and a denominator, isn't it? So it becomes a rational number.
Yes.
It becomes a rational number. So it's not a whole number. I hope you know that. Yes, read better.
Determination of the atomic mass. It is difficult to determine the
It is
mass of an
difficult.
individual. It is difficult to determine the mass of an individual atom. However, relative atomic mass can be determined by comparing the mass of a particular atom with that of an atom of standard reference. The unit of the mass of an atom is atomic mass unit. Initially, John Dalton suggested that the mass of a hydrogen atom be taken as a standard reference of atomic mass unit.
So is it the same thing that we did earlier? It's sort of a revision, right, beta? So mass of an individual atom is very difficult because it's very, very small. So what we do, we did the relative atomic mass. What is mean relative? We are standardizing it. We are comparing it with a standard atom. Which is that atom, beta? Carbon 12. Is it clear? Is it clear? Hello? Is it
Yes,
clear?
ma'am.
Ma'am,
Yeah. And
Yes.
it is taken as atomic mass unit. And how it is AMU. So atomic mass unit has been symbolized as AMU. Who has started this? John Dalton. So earlier John Dalton had taken this reference as hydrogen atom. Which reference he had taken, beta? Hydrogen atom. Later it has been given as carbon atom. Is it
Hydrogen.
understandable? First it was taken as hydrogen,
Yes.
but
Yes.
it was ruled out. It did not work. So now the reference has been given to carbon 12 atom. Is it clear? Is it clear to all of you? Because
Yes,
hydrogen
ma'am.
did not work. Hydrogen did not work. Now carbon
Yes,
has been
ma'am.
taken as a reference.
Yes.
Okay, read better.
Later, 1/16th of the mass of an oxygen atom was taken as the standard in 1961. IUPAC (International Union of Pure and Applied Chemistry) adopted 1/12th of the mass of a carbon-12 isotope as the standard unit to measure relative atomic masses. IUPAC named the unit as the Unified Atomic Mass Unit. Thus, atomic mass unit is equal to 1/12 into mass of a carbon-12 atom. 1 unit is equal to 1/2 into mass of a carbon-12 atom. Hence, the relative atomic mass of the atom of an element is defined as the average mass of the atom as compared to 1/12 the mass of one carbon-12 unit. For example, the atomic mass of oxygen is 16 units.
What are we doing, by the way? Later, because we know the mass of oxygen is 16, but we are comparing with the reference, so it becomes 1/16th. So even we started with Dalton, he had taken hydrogen as the reference, Right, beta? Then which came as reference? Carbon 12.
Yes.
Later, they took reference as oxygen as 1/16th. Then IUPAC came into being. The International Union of Pure and Applied Chemistry, they took carbon. They took carbon and nothing else. They took carbon 12 as a comparison, as a standard unit to measure the other atomic masses of the elements. They took it as U, that is atomic mass unit, not as AMU, but they took only U. So what is the atomic mass unit? This is how you have to relate. You understand now? If you want to find out any atomic mass unit of X, Y, Z, it has to be compared by 112. Is it clear? Into mass of a carbon 12 atom. So what is the
Yes,
formula?
ma'am.
1U is equal to 1 upon 12 into mass of a carbon 12 atom. This is how you have to find out a unit. So what is the relative atomic mass of the atom? Is actually compared to 112 the mass of one carbon, 12 units. So this is how we get the atomic mass of oxygen is, what is the unit beta? 16U. So we'll say atomic mass of carbon is 12U. Atomic mass of hydrogen is 1U. Is it understandable to all of you?
Yes, ma'am.
Yes? Please go through the, what you call it as, uploaded video beta. Now we can see over here the atomic mass of certain elements as compared to, this has been observed by doing the calculation with carbon 12. So you get hydrogen as 1U, helium as 4, carbon as 12, nitrogen as 14, oxygen as 16. This is how, and again you can see over here, can you see this? So it is increasing. As you go down, it is increasing. So 19, 20, 23, then we have got 39, 40, argon again 40, 36, 63, 65, 180. Is it clear? So it is on the, this is how it has been arranged in the periodic table. The atomic mass increasing, it has been arranged according to the increasing atomic mass unit. It is arranged in the periodic table. Is it understandable?
Yes,
You don't
ma'am.
have to remember all these things. This atomic mass you don't
Yes,
have to
ma'am.
remember, okay? You just have to remember the symbol. You will be provided, whenever we are going to do any numericals, you will be given the atomic mass in the bracket. So don't worry about it. Is it understandable?
Yes, ma'am.
Yes? Okay. I think it's the time up, beta. We have not done much today. I'm sorry, because
Yes.
what is the strength of your
Yes.
class right now? Can I ask? What is the strength of your class right now? How much it is?
17.
15.
7, 16. Okay. Very poor, I should say that.
Top.
Because now the science is becoming difficult, beta. If you don't understand, if you don't ask questions, it's going to be a bit difficult for you to understand better. So please be a bit serious about,
80.
because everything is new to you. And that's the reason why I'm always asking you to go through the uploaded video for the revision purpose. At one go, you will not understand. So it needs revision because everything is new to you, beta. Am I clear? Am I clear, beta?
Yes.
So I
Yes,
Yes,
pray and
ma'am.
hope that before I join the Google Meet, all of you, I will come at 8:05. Before that, most of you should have joined. Is it clear? Minimum 20 I want.
Yes, ma'am.
Minimum. Okay. Thank you, beta, for being good and have a good day. Bye, beta.
Bye, ma'am.
Bye, ma'am.
Bye, beta.
હવે કયો લેક્ચર છે?